Hi everyone, and welcome to the ARM Technical Panel. Our aim today is to take a deep dive into ARM's forward-looking engineering thinking. We'll tease out some of the reasons as to why we're taking certain technology directions, such as our new v9 architecture support for confidential computing, which will take secure processing to the next level. Now these are big topics, and the insights our architects and engineers have gained into how the nature of computing is evolving come from conversations with our partners and the ecosystem. ARM is the world's largest computing ecosystem, and that collaboration across hardware and software really defines us. So with that in mind, I'm going to spend the next 20 minutes or so getting insights from three of our brightest minds on topics spanning the technology spaces that we all inhabit. So first off, I'd like to say hello to Mark Hambleton, VP of Software, Suraj Gajendra, Senior Director of Technology and Strategy, and Andy Rose, our Chief Systems Architect. Okay guys, let's get started. So if we look at the big picture, lots going on inside the technology landscape as always, but it seems like there's even more so than ever. Mark, I'll start with you on this one. What is driving all the changes that we're starting to see today around computing?
Thanks, Rene. Hi, everyone. It's interesting.
Computing.
Thanks, Rene. Hi, everyone. It's interesting because workloads are evolving and changing over time. Big Little's a great example of this. In the early days of smartphone, most of the workloads that ran on a CPU could be handled by a small core. But some workloads emerged that needed more and more processing for short periods of time. Big Little was developed by ARM initially to enable us to handle those heavier workloads without breaking the power or thermal budgets of the devices. Technology also progresses in cycles. We go through phases of introducing specialized accelerators, then increasing the capabilities of the CPUs so that you no longer need as many of those accelerators. But then we also develop new workloads which need new and more complex accelerators. It's a double-edged sword, really. Accelerators give you a big improvement in efficiency, but at the same time, they lack flexibility to evolve as workloads evolve. So when you find that workloads become more stable, you often find that, that you can start to invent new and more specific accelerators to handle those workloads. And that's what brings in the age of AI, I guess. And it's this spectrum between flexibility and efficiency that's changing the way that we view compute today.
Yeah, so maybe to build on that a little bit, we have talked a lot about specialized processing inside our walls or on our Zoom calls. But let's drill down a bit. What do we really mean by specialized processing? And maybe most importantly for this event, why should developers care? Suraj, help me with that one.
Thanks, Rene. Everyone should care about specialized processing. I mean, especially, the developers, because it offers a lot of efficiency improvement, like what Mark was saying, in their, in the applications that they will develop, right? Depending on which hardware they're targeting, efficiency improvement, like what Mark was saying, in their, in the applications that they will develop, right? Depending on which hardware they're targeting, they will be able to kind of optimize their workloads into, into the right hardware. Now, one important thing that needs to be aware is we will have to standardize the accessibility of the specialized hardware as much as possible, right? Because when the applications get written, basically based on multiple different hardware choices that are available, it's important to make sure that the common parts of that applications are standardized and accessed in the same way, because that will be able to kind of complement the efficiency that the hardware itself brings about.
Yeah, I think that's a really important point. Just sort of that accessing that compute. I mean, obviously, if it's on the CPU, there's fairly standard ways of doing it. Then the specialism really is needed for the points you guys are making about the sort of really driving that high energy efficiency, the really high performance. But that typically means very specialized hardware, and that's got to be, you have to go through some sort of API, some sort of library. You've got to standardize that interface, otherwise you just can't make use of that in a meaningful way at scale.
Yeah, the more specific and non-standard the hardware is, the more complex the software is that needs to access it.
Exactly.
And that's what's driving us to figure out what the common denominators are here and add that into our system designs or into the architecture itself.
Yeah, so we're really sort of separating that sort of software development cycle from the hardware development cycle as much as possible.
Yep.
Right.
Absolutely.
Yeah, no, it does. Thanks. It's the one buzzword that I think probably exists in our industry across the time I've been involved in it. I'm sure yourself. But now the world is looking for more and more of a platform approach to software. And why do you think that is? Why has that become so much of a hot topic lately?
Yeah, thanks, Rene. Well, I mean, following on from what the others are saying, I think the world is changing, and especially if we look at the embedded world, it's very much changing from sort of embedded compute to sort of connected embedded compute to sort of networks of embedded compute. And to make that work in the real world, you need to be able to get software from different developers, different communities, actually landing on those pieces of hardware. And that it becomes a lot easier if you start thinking in terms of platforms. You know what you're going to land on. And I think also if we look forward into security, which obviously becomes even more important as these things get networked, the sort of platformatization really helps with things like in-field update, which are the sort of cornerstone of compute, the security in this sort of compute.
And now that we're seeing the sort of hybridization of workloads, where something that you would assume just runs on a single node is now being spread across multiple nodes in different parts of the network, it's becoming even more important to have a standard set of APIs, a standard software platform that you land your hybrid workload on top of. That enables a flexibility in the way that we use our compute with dynamic migration of particular tasks throughout the network. But as you do that, it has a strong coupling to the level of trust that you have in the platform beneath you. So security and the trustability of that platform suddenly becomes one of your key constraints as to where you're prepared to allow parts of your workload, parts of your data to reside.
It does, but I think interesting, we're talking about standardization, but I think that actually gives the hardware community the ability to specialize or differentiate beneath that standardized layer. So, it's not about sort of commoditizing, all hardware looks the same. It's kind of like this platform looks the same, and the hardware can do what it needs, fit the PPA budget it needs. Yeah,
let the software take the strain for abstracting the hardware, but still provide the guarantees from the hardware for security and trustability.
Yeah.
Yeah, and I feel like, to Mark's point on security, it's been a theme that's obviously been constant around technology. If you look at all the issues that we had with Spectre meltdown years ago, but lately it just seems more real. It seems like people are really putting a lot more thought into security as part of their fundamental design. It's not a hygiene issue anymore. It's got to be somewhat fundamental. Suraj, I'd like to get your viewpoints on that because I know that's an area that you spend a lot of time thinking about.
Sure, Rennie. Yeah. So fundamentally, one of the biggest change that we're actually seeing these days is the workloads are actually getting developed in the cloud and deployed onto the edge devices, right? So that adds another level of security requirement into the whole, platform, right? So, there should not be, for example, you have to make sure that the operational data and the control data, if it's robotics or an autonomous vehicle, that cannot be hacked. So the entire infrastructure from cloud to edge has to be very secure, right? So now, that is where, the security features that we are adding in the hardware, the security features that are very critical in the middle layers of software, and, a secure environment in the cloud for the developers to write those workloads are very, very important. So, that's why, you see security becoming one of the fundamental requirement, one of the fundamental aspect of, application development going forward.
Yeah, that links with what Mark was saying about those applications actually being spread across multiple compute nodes. Right. A lot of the time you're not targeting a single node; it will be spread out, and now you've got to trust multiple devices, and you've got to understand what those trust signals coming back from those devices means, which links back again to the standardization of the platform. Can I trust you? Yes, that yes has got to come back in a way that means something to you,
absolutely.
Not specific to each node.
Yeah, so 2020 was a big year for us, as you guys all know, relative to some new announcements we made on products. And one of the most important was the announcement of V9. And when we did our Vision Day and then some other announcements in June, we talked about confidential computing. And Andy, you specifically spent some time talking to the audiences about that. I'd like to have you expand on what that really means for developers. How does it fit in? And what's the future for developers as it applies to confidential computing?
Yeah, well, I think confidential compute really sort of fits in with what we're talking about here, because it's very much the sort of protection of data while it's in use. And in the extreme, it's protection of data even from privileged software on the platform. So it's about sort of having that environment where an application developer gets a very strong guarantee of what they're dealing with and the amount of things in the system that they have to sort of trust is limited almost. And so that gives the developers the freedom to actually spread their applications out with more confidence. So I think confidential compute is one of these sort of cornerstone sort of ideas, cornerstone technologies, which will help this sort of what Mark was calling the hybridization of workloads earlier. I think it's one of those things that really gives these sort of these execution environments where your code and your data can be well looked after. And I think one of the things with confidential compute is it's very much a sort of a continuum. I mean, some of the things we were talking about earlier about building the right hardware and lower level software for that's right for purpose. I think confidential compute's sort of embracing that. I mean, Mark.
Yeah, and when you think about the life cycle of TrustZone, there was an adoption curve for TrustZone going through, that took many, many years. One of the challenges with confidential compute is actually understanding the different workloads and how they're going to make use of the new architecture features that we're bringing in. Each segment that is going to adopt some of the confidential compute technologies is going to have different requirements, different life cycles for deploying things. And then when you talk about hybridized workloads, again, you've got multiple technologies that would largely live in different segments coming together and trying to deploy trustable systems to operate on users' data. It's going to be really interesting to watch this play out over the next few years.
Yeah, and just want to add one more point to that, right? Again, one of the key aspect of confidential compute is, again, if you have a hybrid system where you have a CPU chip and an accelerator connected over PCIe, by using ARM's confidential compute technology, you can actually have an end-to-end secure realm, for example, right, between those hardware. So it's not just the compute element, but also the resources that it utilizes to talk to other intelligent chips on the same platform. You can have a much better secure environment.
Thanks, guys. So we're here at DevSummit, and our audience is developers. And I'm reminded of a famous CEO quoting developers, 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 developers. So when we think about specialized processing, and it's really cool, it's really exciting, we talk about it a lot, but what are you actually doing to make it easier for developers to deploy platforms that use this? Mark, let me start with you.
Yeah, thanks, Rene. So one of the obvious things that we're doing is we're trying to make sure that each of the specialized processing technologies that we invent and develop are actually enabled in software in the upstreams that developers are most commonly using. We're also trying to build reference systems, reference software stacks that we can show developers actually how to make use of those specialized processing elements. It's not the most straightforward thing to do, right? We're providing system architectures which try to show the right way to knit these things together, but then software stacks that land on these reference hardware platforms that demonstrate exactly how to use it, bring all of the pieces of software that we've enabled together in one place.
Yeah, I mean, just to add on a couple of points there, Mark, right? I think it's, again, ARM, for our future looking, like for the IPs that are coming on our roadmap, we actually build fast models. We actually build IP models that can enable developers to start their software development as early as possible in the whole solution development cycle. So we do it, like, for example, we invest in specific markets in order to enable all the other tools that the developer may need. For example, my colleague Mohammed announced the total solutions for IoT yesterday, right? So which basically is providing the capability for developers with ARM hardware in the cloud, basically the models in the cloud, in order to for the developers to make use of and develop software as early as possible. We announced Sophie, which is basically a software framework specifically for autonomous machines and autonomous vehicles, for example, right? So that developers can actually write the workloads as early as possible in the cloud and deploy it onto the edge. So we actually have a range of software reference platforms, models in the cloud, and an array of tools for developers who can actually make use of art, and build their software.
Yeah, thanks, guys. You know, one of the things that I know we all like to ask ourselves when we're involved in these technology discussions about platforms and security and software is the big so what question. So I'm going to pose that one to you guys now. So what? All that we just talked about. How does this all translate to opportunity for the ARM ecosystem for the next 5 years? Mark, again, let me start with you on that.
So thanks, Rene. I think I said this last year. I truly believe that ARM's going to be the compute platform of choice in every segment. And I think that's going to happen within the next 5 years. The ARM ecosystem, the hardware ecosystem, is uniquely positioned to build the right scale, size, power envelope, thermal envelope piece of hardware that the software ecosystem will be able to use to great effect to build markets, build on markets that exist, but build new markets of opportunity for themselves. Our vision as ARM is that the world's software runs on ARM wherever you are developing. So I believe every developer on the planet eventually is going to be developing for ARM and probably on ARM.
Yeah, and I think the ecosystem gets to help us accelerate that with this platform story, because it does decouple that hardware development, hardware specialization from that software. And with those software platforms, what Suraj has been talking about with developing in the cloud and landing on those platforms all comes together and hopefully can move really fast. That offers real opportunity through the ecosystem.
Yeah, absolutely.
Yeah, and then one point from my side is again, the technology in each and every space is actually evolving rapidly, right? Yeah. So the next 5 years is we're actually super excited to be in this position, especially as ARM, so that we can actually feed in all of these tools that the developers can actually use to kind of like enable, some fantastic applications, for all the industries that we actually play in.
Thank you so much for all your valuable insights. That was really interesting. Really was a great discussion on developer technology and specialized processing. Now, there's clearly a fundamental change in the way that software has to be developed and maintained. We can no longer treat the world as completely separate domains as connectivity rises. It's increasingly evident that these new workloads, such as AI, matrix, etc., will be deployed across the cloud and the edge. Accessing specialized processing will be key for developers to be able to deliver on the promise of the performance and the technology of tomorrow, including ARM's v9. Thank you again for joining us, and enjoy the rest of DevSummit.